Welcome back. In this video, we are going to talk about market for insurance. We will try to understand that how does the market for insurance operate? What are the fundamentals that powers the insurance market? We have seen that there are three kind of people, three kind of decision makers in the market: risk averse, risk neutral, and risk loving. We do gamble sometime, but that's very rare. Most of us, and for most of the time, are really risk averse. Big companies, because if they are working with the same kind of risk all the time, so in the long run it pays them to be risk neutral, but individuals typically are not risk neutral. Most of us are risk averse. If that is the case, how can insurance business exist at all? Because who is going to sell the insurance if everyone is risk averse? So Devi Daughter, who is a professor in MIT, and I am taking his lecture note as a reference material, he talks about three distinct mechanisms through which insurance market operates, and these three distinct mechanisms are risk pooling, risk spreading, and risk transfer. To understand that, first of all, let us understand the law of large number. If we toss a coin once, and if the coin is a fair coin, what is the probability that we are going to get head? That is P, and if it is equal to half, because it is a fair coin. So if you are going to toss n times, how many times you can get head on average? You can get n by 2 times you are going to get head. And so if you are tossing a coin once, you cannot be certain that whether you are going to get head or tail. But if you are tossing a coin for a really large number, you can be more or less certain that if it is a fair coin, half of the time you are going to get head. And how do we get that? This is where the law of large number comes into play. The variance around the mean depends on the number of coin toss, and the formula for this is P multiplied by 1 by P divided by n. So if you are tossing it once, the variance is 0.5, and this is also 0.5 divided by 1, that is 0.25. If you are tossing it twice, the variance is 0.25 divided by 2, which is 0.125. If you are tossing it 10 times, it is 0.025. It's 100 times, it is 0.0025. You see that as n is increasing, the variance is decreasing. So when it comes to one toss, you couldn't be certain. But if you are pulling independent risk, that probability that one person loses is independent of the probability that the other person loses, by pulling these different independent risks together, an insurance company can treat these uncertain outcome as almost certain. Like out of 100,000 times, an insurance company can figure out that 50,000 times it's going to be head, almost certain about it, because variance would be way lower as n is increasing. So an uncertain event will become certain. So risk pooling is basically a mechanism to provide insurance. What it does, it defrays the risk. What is defraying? It's making risk disappear if by exploiting the law of large number, insurance company can defray the risk. Let us look at an example. Let us say that you have 2.5 lakh rupees. Okay, that's the value you have. There is 1 by 250 chance, it means 0.004 chance that you would lose money. And because you would lose money, there are two states, one in good state, that happens with 1 minus 0.004 probability that you have 2.5 lakh rupees, and bad state 0.004, you have 0 rupees, you get your money stolen. And as we know that people are risk averse, they have convex preference. If by ensuring, by having the same kind of consumption in both the periods, if you have, your utility would be higher, you would be better off. So the idea here is that for one person this loss is very, very significant. The certainty equivalence will be much lower. This person would be willing to pay a significant amount of money to insure. So what we can think, that let us bring 100,000 people together, and they all have this 2.5 lakh rupees, and just for simplicity we are assuming that everyone has this 2.5 lakh rupees. And if they pull, or each one of them pay, let us say 1000 rupees INR, they pull it together. And if they pull it together, the total collection is going to be 100 million. And in expectation, because out of 100,000, how many people will lose? 100,000, 0.004, and so 400 will roughly lose all the money. And so 400 people will lose. So if they need to be compensated, each one needs to be compensated, let's say 2.5 lakhs, you are back to 100 million. So they all can be roughly compensated. So everyone who is participating in this pool becomes better off, because the risk decreases by paying, let us say, 1000 rupees premium. And that is making everyone better off. So if we use the law of large number, it would say what would be the variance of loss, because we are bringing how many people together? We are bringing a lakh of people together, and each one is giving 1000 rupees. So V loss is going to be probability of loss multiplied by 1 minus probability of loss, and N is going to be 100,000, because that those many people we are bringing. So 0.004 multiplied by 0.996 divided by 100,000. So roughly I have done the calculation, 3.984 multiplied by 10 to the power minus 8, and so standard loss is going to be roughly 0.0002, very, very small. And so you can use the formula you must have done in statistics. What is the probability that loss is going to be between, let us say, that between 0.004 plus minus 1.96, because you have very large number, then a binomial distribution can be approximated as normal distribution. So your probability of loss is going to be 0.95. So there is a 95% chance that out of 100,000 people, 361 to 439 losses is going to happen for the house. So of course it's very near, rather than having a big swing, you have very closer number. And so risk pooling in this way is decreasing the risk for anyone. You can increase the N further. As N increases further, variance decreases even further, and then everyone is better off. So one can say that bringing these independent risks together is really Pareto improving for everyone. So this risk pooling or risk sharing works really well when there are independent risks that can be pulled together. But in life, there are many times when risks are not independent. Like for example, there are earthquakes, and if we are talking about that, that 2.5 lakh rupees worth of a house, so earthquake would destroy many houses together. Perhaps flood or COVID, all these things would destroy lot of houses together. So in this particular case, we can say that calamity will struck the society simultaneously, and therefore to some extent these risks are non-diversifiable, because how we are helping there? By pulling all the people together, independent risks together. Here we do not have independent risks, and because of this reason you might have noticed that insurance companies do not cover such situation. They say force majeure or something like that. They have a word that when there is a natural calamities like flood, nuclear war, and like COVID, for which they have no control, they do not cover such situation. So what can we do in such case? In such cases we can have risk spreading. Risk spreading can still work. The only thing that you require is that there have to be some people who are not affected. That is what is important. So why does it work? Because we have concavity of risk utility function. We can say utility function. What it means, that taking a little bit of money from a large number of people, um, incurs, we can say incurs less social cost than taking a lot of money from a small number of people. And that is the nature of the utility function, the way indifference curve are shaped. So in this particular case, these risks cannot be covered by insurance companies, but government can insure people in such cases. Like they can have victim compensation fund, they can have disaster relief, they can have health insurance or health facility. We are not thinking them in terms of insurance, but think about it, what insurance does. It alleviates the pain in case of bad outcome. That's what exactly these things are doing. So they can also be, these government policies can be considered as a way of providing insurance, and they are providing insurance by risk spreading. So let us talk about the last one, and that is risk transfer. The risk transfer works on a very simple principle, that utility cost of risk is declining in wealth. What does it mean? It simply means that less wealthy people could pay more wealthy people to bear their risk, and both parties would be better off. Let us take an example. So let us take two kind of people, one who is wealthy, another who is not wealthy. They have the same kind of utility function. Their utility function is given by root under x, and the poor person can have 100 rupees with probability half, and with probability half, let us say he loses 36 rupees. So his expected utility is going to be half multiplied by root under 100 plus half multiplied by root under 100 minus 36, and that is half multiplied by 10 plus half multiplied by 8, and so that is equal to 9. So in equivalent term, this is equal to 9 square, 81 certain income. So this person would be willing to pay up to 19 to avoid taking that risk, because he had 100, what he is getting is has certainty equivalent of 81, so it means he would be willing to pay up to 19. Let us take a much richer person and let us say that his income is 100 multiplied by 10 to the power 4. What is going to happen? His expected utility is going to be half multiplied by 100 to the multiplied by 10 to the power 4 root under plus half 100 multiplied by 10 to the power 4 minus the loss has to be the same everywhere. This is going to be 1000. This is roughly going to be equal to, let me calculate. So this is going to be equal to 999.982, and if we calculate and if we figure out its equivalent, it's going to be 999.82. It means this person is willing to pay 18, because this is the certainty equivalence. This person is willing to pay 18 to that lottery. So this richer person can insure this poorer person for a value, let us say for example 18.5. they both would be better off, because this 18.5 will make this richer person better off and also the poor person better off, because he is willing to pay up to 19 but he has to pay only 18. And this is the way one example that author gives is Lloyds of London used to perform the risk transfer role in this particular manner. It took upon a large idiosyncratic risk like satellite launches, oil tanker transport and Titanic. So the poor persons are getting insured by rich persons. So these are the different ways an insurance market can work. Thank you.